All right, for special cases of systems of equations, we've already done some of these things. Before anything, I want you to work through some of these on your own. Go ahead and press pause and then play when you're ready. So for number one, the first thing we need to do is distributive property. So it becomes 3x plus 12 equals 2x plus 17 plus x minus 5. Now we need to combine like terms on the right-hand side. So we still have, 3x plus 12 on the left-hand side. On the right-hand side, we now have 3x plus 12. What you'll notice is they both have a positive 3x and they both have a positive 12. If you were to move the 3x from left to right, what would happen is you would have 12 equals 12 because the 3x's cancel out. So 12 equals 12, is that true? Yes, it is. So this answer is infinitely many. Next one, same thing. Distributive property, 2x plus 10 plus 3x equals 5x plus 14. Combine like terms on the left-hand side, so 5x plus 10 equals 5x plus 14. You will notice that you have the same 5x on each side, but you don't have the same constant. So if we move the 5x from the left to the right, they cancel each other out, and now I have 10 equals 14. Well, 10 does not equal 14, so this answer is no solution. So infinitely many and no solution. It says with your partners, obviously you're not going to do it with your partners, you're just going to do it on your own, but it says to use substitution. So the first thing we're going to need to do is solve the top one for either x or y. I'm going to solve for y, which means I have to subtract x from each side. So negative x plus 1 is going to go in for this y. So 4x plus 2 times negative x plus 1 equals 4. 4x plus negative 2x plus 2 equals 4. So now I have 2x plus 2 equals 4. Subtract 2 from each side. 2x equals 2 divided by 2, and x equals 1. We found the x, we need to find the y. So y equals negative x plus 1. So y equals negative 1 plus 1. Y equals 0. So our coordinate pair is 1, 0. Now we're going to use elimination for this next one. I need to multiply the top by negative 2. So it becomes negative 4x minus 2y equals negative 2. And we're going to keep the 4x plus 2y equals 4. By doing this, we canceled out the x's, we canceled out the y's, and 0 is all that's left on the left-hand side, and I have 2 on the right-hand side. This obviously does not work, so it's no solution. Now in order to graph them, we have to make them both y equals. So this one, all we have to do is subtract 2x from each side. And for this next one, we not only have to subtract 4x from each side, but we also have to divide everything by 2, so y equals negative 2x plus 2. So for the first equation, we start at positive 1 and go down 2 over 1. Since our y-intercept is positive 1, that's why we started at positive 1. And since our slope is negative 2, remember anytime you have a whole number, you put it over 1. So for our next one, we start at positive 2 and again go down 2 over 1. What you'll notice happens is we create parallel lines, so this one is no solution. Number 6 is what happened when we tried to solve the equation with all three methods. What you'll notice is on the first method, substitution, there wasn't a 2 attached to the x, so we're going to ignore that one. But let's talk about the elimination and the graphing. So the graphing, it never crossed, and the elimination was no solution. So all of them, there was no solution. So elimination and graphing, there was no solution. So algebraically, the reason why it happened is because the variables canceled out. And the constants weren't the same. Graphically is because the slope was the same, but y-intercepts were different. Now looking at this bottom one, again we're going to do substitution. So we're going to solve for x, and x equals negative 2y plus 2. And we're going to plug negative 2y plus 2 in for this x. So 2 times negative 2y plus 2 plus 4y equals 4. We're going to do the distributive property. So negative 4y minus 4, plus 4, plus 4y equals 4. You'll notice that the y's cancel each other out because negative 4y and positive 4y cancel each other out. 4 equals 4, so this one is infinitely many. Next one, we're going to solve this by graphing. So we need to solve for y. X plus 2y equals 2. So we're going to subtract 1x from each side. 2y equals negative 1x plus 2. Divide by 2. And y equals negative 1/2 x plus 1. Start at positive 1 and go down 1 over 2. The next one, 2x plus 4y equals 4. We're going to first subtract 2x from each side. Then 4y equals negative 2x plus 4. Divide everything by 4. And again, y equals negative 1/2 x plus 1. Remember that the 2 over 4 reduces down to 1/2. So again, we start at positive 1 and go down 1 over 2. So what happens is they're the same line, so infinite. And finally, elimination. We have x plus 2y equals 2 and 2x plus 4y equals 4. I'm going to multiply the top by negative 2. So it becomes negative 2x minus 4y equals negative 4. And I have the bottom is going to just transfer over. And you'll notice that it cancels out the x's, the y's, and the constants. So 0 equals 0, which is true. So algebraically, so this one was infinitely many. So the thorough explanation of why this happened algebraically. This happened algebraically because the variables all eliminated, and so did the constants. So 0 equals 0. Graphically, the reason why this happened graphically is because they were the same line. So every single point was the same on each equation graphically. All right, so there is no solution when
the variables are gone, but constants are left over. An example of that would be if you had 2x plus 4y equals 10, and negative 2x and negative 4y equals 3. You would see that the variables on the left-hand side are gone, but on the right-hand side you have 13, so that's not true. There's one unique solution, excuse me, one solution when there are variables left in the equation. So if you had 2x plus 4y equals 6, and you have negative 2x minus 3y equals 2, what would happen is the x's eliminate, but I have 1y, and this is 8. So that would be one unique solution, and you could plug y back in to find x. And there are infinite solutions when variables are gone and constants are too. Example, 4x plus 3y equals 6, and negative 4x and negative 3y and negative 6. So gone, 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 0 equals 0.